Now let's take a quick look at the alternative sources of energy, the possible energy sources that we can use in the future. Now, the definition of an alternative source of energy is one that's different from those commonly used today. Now, this goes a lot deeper than the textbook definition here. When we refer to alternative sources of energy, we are talking about other sources that have less of an impact on the environment, that we have more resources of, that are renewable, so on. There are many different aspects to alternative sources of energy. So here's a list of the type of sources for energy we have today, primarily fossil fuels, nuclear power, nuclear fission specifically, hydroelectric, moving water. We have wind and some solar are starting to come into play. But the alternative sources that we are hoping to develop and become more prevalent in the future would be solar power. We could also add wind power to that because the wind is driven by solar heating. There's geothermal, or the heat from inside of the earth. There's also nuclear fusion, of which we've already discussed. Now, what would be the advantage of turning to one of these alternative sources of energy? Here we talk about energy conservation. This is not to be confused with the conservation of energy, which is the principle that energy can't be created or destroyed. When we talk energy conservation, we just mean not using as much energy, so our generation of, say, electricity and heating, that demand is decreased and falls within our resources. One of the advantages to energy conservation is that it reduces the need for additional energy. We don't need to build more plants. We can make do with what we already have. It also saves money for the consumer. If you use less energy, then you don't have to pay for that extra energy. Energy conservation can make demands easier to meet. When you have a large city, the demand for energy is much, much higher. But if every individual person cuts their demands by, say, 25%, then that is a huge decrease in demands for energy. Also, with lower demands, we can improve the efficiencies of the facilities we already have. If we improve the efficiency of what we already have, then that can better accommodate the needs and demands of the current population. Now, the interesting thing is we have a really good energy generation network. The problem is that a lot of that energy is wasted. And that's both from an individual and a technological problem. Individual, because what do? We leave our phones plugged in all night long, even though it only takes a couple hours to charge. We leave lights on. We insist that television runs 24 hours. You can see the problem. We are using a lot of energy as individuals, more energy than we need to. It's a technological problem because the technologies are just too inefficient at the moment. For instance, a car's engine, it burns petroleum and uses some of that energy to move the car. Now, the amount of energy that the fuel produces, only about 40% of it is actually converted to kinetic energy. The other 60% of it is released into the atmosphere in the form of heat or chemical reactions. And so it's a continual waste problem, both individually and technologically. And so if we can conserve energy, the more we conserve it, the more efficient our facilities can be, the less demands will be, the less we'll waste in the end. And this is one of the big pushes in our society today. And whether you believe in climate change or not, whether you believe in this whole economical situation of energy or not, there are so many advantages to energy conservation on an individual scale, as well as a large scale, say a business or a city. And so it's just smart all around.